Alpha particles have the shortest ranges, and matter that is only a few millimeters thick will stop them. They will not penetrate a thick sheet of paper, but will deposit all their energy along a relatively short path, resulting in a high degree of ionization along the path. Alpha particles consist of 2 protons and 2 neutrons bound together into a particle identical to a helium nucleus. Alpha particles are emitted by radioactive nuclei, such as uranium or radium, in a process known as alpha decay. This sometimes leaves the nucleus in an excited state, with the emission of gamma ray removing the excess energy. Most smoke detectors contain a small amount of the alpha emitter, mercurium-241. This isotope is extremely dangerous if inhaled or ingested, but the danger is minimal if the high source is kept sealed, because alpha particles occur naturally, but can have energy high enough to participate in a nuclear reaction. Study of them led to much early knowledge of nuclear physics. Beta particles have longer ranges, typically penetrating matter up to several centimeters thick. Those particles are electrons or positrons that have one of the unit of either negative or positive electric charge and are approximately 1 to 2,000 of the mass of a proton. These high energy electrons have longer ranges than alpha particles and deposit their energy along longer paths, spreading the ionization over a greater distance in the material. Beta particles are high energy, high-speed electrons or positrons emitted by certain types of radioactive nuclei, such as potassium-40. The beta particles emitted are a form of ionization radiation, also known as beta rays. Also, inverse beta decay in one of the steps in nuclear fusion processes that produce energy in cytostars. Beta decay commonly occurs among the neutron-rich fission bioproducts produced in nuclear reactors. Beta particles are able to penetrate living matter to a certain extent. Radiation intensity from a small source of radioactive material decreases as 1 over the distance squared, and can change the structure of struck molecules. In most cases, such change can be considered as damage, with results possibly as severe as cancer and death. Beta sources can be used in radiation therapy to kill cancer cells. Gamma rays can penetrate matter up to several meters thick. Gamma rays are high-energy photons that have no electric charge and no rest mass, the structural energy of the particle. They will travel unimpeded through materials until they strike an electron or the nucleus of an atom. The gamma rays energy will then be either completely or partially absorbed. Enabling atoms will be ionized. Therefore, these 3 types of radiation interact with matter by losing energy and ionizing surrounding atoms. Gamma rays are a form of electromagnetic radiation or light emission of frequencies produced by subatomic particle interactions, such as electron-positron annihilation or radioactive decay. Gamma rays are generally characterized, and electromagnetic radiation have the highest frequency and energy, and also the shortest wavelength, below about 10 picometer within the electromagnetic spectrum. Due to their tissue-penetrating property, gamma rays, X-rays have a wide variety of medical uses, such as in CT scans and radiation therapy. A study done on Russian nuclear workers exposed to external whole-body gamma radiation at high cumulative doses shows the link between radiation exposure and death from leukemia, lung, liver, skeletal, and other solid cancers.